Should we start? Okay, friends, welcome to Nehru Science Center's virtual program.
Yeah.
Not gone live yet. Okay. How are you, Amir?
Good, sir. Thank you very much. Good that you could join. Good to see you.
I thought you already gone live. Okay, I came late.
No, we were just about to go after.
No. Upload. When I told both of you, please. So how are things, Savi?
Yeah, live.
Okay.
Please go ahead. Yeah.
Okay, sir. Friends, once again, welcome to Nehru Science Center's virtual program. As you know, we are all, though we were under lockdown, even though we are open for public now, but still there are some basic facilities or transport kind of thing which is not still available for general public. So getting few visitors every day, not very encouraging still, but we can understand that. But we are trying to connect with our audience regularly by organizing various programs. And this today's special program is in, I should say, we are all aware a lot of hype has been created and we are all excited about the coming event on astronomy. We have got very good response so far as astronomy events are concerned. So we thought the super great conjunction which is going to happen on 21st of December, which is a very, very rare event. Many of you are aware now by this time that last time it was seen in 1623. So a lot of things are there about astronomy. We all are aware. We are always willing to watch sky and want to know more about planets. But where to start? So sometimes many people think there are many big institutions, but you can start on a very basic science, planetary science yourself. And how to do that? For this, we have with us Mr. Samir Durde from Ayuka Pune. I think all of you are aware, those who are slightly having interest in astronomy. Perhaps they are aware about Ayuka. I did not tell more about that. But since we are slightly behind the schedule, saying that we want to try out planetary science and how we can do it, or means all our astronomy amateur astronomers or people who are interested in doing day-to-day astronomy, how they can do it. That's what Mr. Samir is going to tell us about in maybe next 35 or 40 minutes or so. So let us first I will request my colleague Ms. Juma to introduce the speaker, and then I will request Mr. Samir to take over and tell us about how we can have this planetary science on ourselves. Okay. Yeah. Juma? Yeah, over to you.
Hello everyone. It's our great honor to have Mr. Samir Dhurde today for the lecture. Especially it's aiming for the school children. I hope they will get benefited out of it. Mr. Dhurde is a trained radio astronomer and he has been working at Ayuka Pune for the last 15 years. He has completed his master's degree with a specialization in astrophysics from Pune University, and currently he is in charge of the popular outreach program that is being organized by Ayuka Pune. So I won't keep you waiting for long. Let's welcome to the speaker.
So, welcome to all the people, all the students, all the parents, all our viewers at the Nehru Science Center channel. I'm here today to discuss with you planetary science, and it's going to be about planetary science, something that you can try out. Now, I was just introduced as a radio astronomer. In fact, I still practice astronomy, and there's very little radio in it because there's also a lot of lovely occurrences which can be seen with small telescopes, big telescopes, which use light which your eyes can see. So therefore, I am currently quite busy loving the things that are happening in the sky and looking at them through our small telescope. I'll come to radio telescopes maybe slightly later in the talk. But other than that, I think you can also describe me as one of my hobbies is being a foodie. Okay, now you say what's that to do with this talk? So when I say I'm a foodie, and if I could see all of you, I wish I could ask you to raise your hands to say who all here are foodies. And when I say when you say that you're a foodie, I would ask you, what do you do? How do you prove that you're a foodie? Right. So when you do that, I think some of you will say, okay, I could actually just say, okay, I read a lot of recipes. I look at MasterChef on TV, and I look at a lot of pictures of food, etc. Is that enough? Can I just read about food? Can I just look at food? Can I just smell food and finish and say I'm a foodie? I guess not. I would at least have to go out and eat really good food, whether cooked by my mom or family members or at a restaurant. And further still, if I am to call myself a really hardcore foodie, I would love to cook that thing myself. That is when I would probably be even considered as a chef or a person who actually loves food. So similarly, when I say that one needs to be a planetary scientist or one needs to be interested in a planetary science, then I have to be somebody who is actually practicing a little bit of planetary science. So without that, I think it's quite incomplete to say that I'm a planetary scientist. Okay, so what I am going to show in this few minutes that I've got with you is to know what is planetary science, know some of the grades of planetary science, and then slowly also introduce you to an event which might be a stepping stone or a starting point for your own journey into planetary science. Okay. I will also mention to you some resources you can use or make yourself. But then what is this planetary science? When I was asked to make a presentation on this particular event which is happening this week, I'm sure which you're aware of, and if not, please go to the Facebook page, scroll down the page of Nehru Center and have a look at the many mentions of the Jupiter-Saturn conjunction. And I'm sure there are other good talks there as well. So have a look at them. So we are talking about planetary science, and here is a chance to try it out this week. Yes. So we are going to have a beautiful event coming up this week. But before that, I thought I'll just introduce you to what are planets, what is this planetary system that we are studying, and what are the advances that have happened till now. So I'm Samir Dhurde, and I work at the Inter-University Center for Astronomy and Astrophysics. I'm an astronomer, as has been mentioned, but I also like sharing things about the solar system and things outside it as well, the whole universe, in fact. So planetary science itself is a very limited resource, limited subject. So if I have to talk about planetary science, I have to tell you that I am referring to the planetary system, which we call our solar system. Okay? And this is a kind of a picture which you must have already seen. It's a cartoon picture of our solar system, and not very ideal, but you can at least see that our solar system has a lot of things which are gravitationally bound to our sun. The sun is a major star. It's a star which has been there for 5 billion years. And what we have found over our discovery of astronomy is that there are many, many other things which make up the solar system. And the important thing is that they are gravitationally captured by the sun. So basically, its gravity acts on all of these and makes them go around either directly or indirectly. So in this, of course, there is the sun, and we have the 8 planets. So I need not say out the names of these, but importantly, and sometimes this is left out in textbooks, etc., there are also 5 dwarf planets, and there has been a lot of exciting and also controversial talk about one of the planets, the 9th planet, Pluto, being changed the designation was being changed to a dwarf planet. Dwarf planet, there are 4 more. Then there are other bodies like comets. Just now in July, August, you had heard about a bright comet which had come to our skies. But then at any given time, there are at least 5 to 10 comets up there in the sky, and they are closer to the sun. However, the only problem is that they are small and they may not be so bright like one of the rare comets which visit the inside. Other than that, there are some things called minor planets. Now, this is a broad category called minor planets, but this, of course, also includes some things which you popularly call asteroids. But then, of course, it's a very simplified picture like the one presented, cartoon one presented here on the right side of the presentation. The thing is that asteroids are not the only thing in the solar system, other than the few things I just mentioned. There are many other things which are like asteroids. They do not qualify to be planets or dwarf planets, but then they have to be assigned various names. So they are assigned names by the places they are at. So asteroid belt is between Mars and Jupiter, very well known to you. And then there are objects which are going around the path of Jupiter. They can be along the orbit of Jupiter, or they can be between Jupiter and Saturn. There are some objects beyond Neptune called trans-Neptunian objects. And then beyond that is something called the Kuiper belt. Okay. And beyond that is the Oort cloud, which is mostly consists of the comets I just mentioned. So there are several things which cannot be classified, and there are like thousands of these. And we have a special class called minor planets to include them all. That's there. Then there is dust and gas. Now, even small rocks like ones which may be a football size or something could still be called an asteroid. But then there are things which are very fine, which are like dust, which we know very well, like sand and fine particles like dust. And the solar system is full of them. Okay, so this is also there, and it also has in a large number. They also play a significant role in our solar system. Then there is a lot of gas. Okay, now gas you cannot escape out. They are basically like molecules. They're very dilute, very thin, but it is still there. Okay, and most of this is remnant of a previous generation of things which existed in the solar system. So that is kind of a study which a planetary scientist does. So planetary scientist basically studies all these things or any of these things, because again, although planetary science is a small part of astronomy, planetary science itself is divided by the study of these particular things. So some people may study the sun, some people may study any of the 8 planets or all of them together. Some may just be studying one dwarf planet or all of them. Some may be studying comets specially. Some may be studying asteroids. Okay, just now you must have heard there's an asteroid mass collection. Some material was collected from an asteroid, and it was brought back to Earth by the Hayabusa mission. Okay, so some people are studying things like that, and some people do study dust and gas so that we can look at some of the oldest remnants or evidences of the previous generation of things which were there before the sun. So these are very important to study, and that is what is mostly studied by a planetary scientist. There is also one important thing which I should not forget, that there is other stuff like us, right? So we do not fall into the category of any of the above, and we are not dust and gas, but we are there, and we are a very important part. Also, there are people who do want to study and know about the presence of life in other places in the solar system. Okay, either presence of life itself or the presence of conditions which are favorable for life like ours or otherwise. So this also somehow falls under the purview of planetary science. So people may study, let's say, the mathematics of it. Okay, they may study the physics of it. They may observe and take, ephemeris, which is basically find out the path of the objects going around the solar system. They would beat me up if they see this cartoon in which all the orbits are perfectly round for all the planets. They are not, but still they are well predictable because of the amazing amount of observations which have happened about the planets and other bodies in the solar system. So that's an astronomer at work. People might be looking at the chemistry of planets or planets' atmospheres, okay, their surface, and there might be people looking at geology of planets and moons, etc. There might be also people, as I said, who are interested in exobiology, so biology of things beyond the Earth. Okay. So all these sub branches are also there out there for all the students who are interested in astronomy, astrophysics. This is a particular sub branch that I'm bringing to you. I'm bringing to your notice with this talk here. So great. Now let's slightly rewind back and look at how the perception of science, the solar system, the planetary science, and science in general has changed over the years. Okay? And it was just mentioned that this conjunction, which we are going to talk about at the end, or you may already know about it, happened close to 1623. So in the 1600s, there was this scientist Christian Huygens, a Dutch scientist, and I love this quote which he had made in the 1600s. Remember, 1609 was the first use of a telescope by Galileo, of course, for astronomical purposes. So Galileo was, of course, he's very well known, and everybody would mention him. So I thought I would mention somebody else, and this person has a big recognition. Let's see what he thought of the planets in the sky, and he, of course, had used a telescope. And so what he says is, how vast those orbs must be, and how inconsiderable this Earth. Okay. So sitting here, he did subscribe to the fact that the planets are big, okay? And of course the sizes comparatively were not known, but he says how vast those orbs must be, and how inconsiderable this Earth. How small is this Earth? Okay. The theater upon which all our mighty designs, all our navigations, and all our wars are transacted is when compared to them. So he's wondering how small is our Earth on which we do all our drama, theater, all our planning, all our navigation, travel, etc., all our wars, all our love, everything happens on this Earth. Okay, and compared to this tiny Earth, how big they might be and how big the solar system might be. That was a question, and we didn't know answers to that. We did not know the distances, we did not know the sizes, we did not know anything about the planetary system. But this person had something which I personally think is a great habit and a characteristic of a scientist, of any person who wishes to be a scientist, and that is being hands-on. Okay, so they also have to work, they have to use their heads. It's not just about reading popular books or looking at documentaries, it's also doing a lot of hard work. Okay, so why am I talking about this person? It's because, you see, he not just looked through a telescope, he looked around, he looked deeper, he made improvements in telescope, including the invention of something called the Huygens Eyepiece, which made it possible to see clearer images. Okay, but of course that's mostly used in microscopes. But he was an optics person. Okay, so he used to tinker around optics, the pieces of glass which can show you things better, and he is well known for his study of the rings of Saturn. Just imagine, you are here in the modern age, in the 2020 year, and how many times have you seen Saturn? If you say you're interested in planetary system, that is something I'll keep poking you about, that we need to go out and do things. So Huygens did that, and of course he also invented the Huygens Eyepiece, as I said. And to remember him, when the first probe was sent to Huygens, when the first probe was sent to Saturn, the lander of it was called the Huygens probe. Just imagine how important this person must have been. So Cassini was another person who also studied the rings of Saturn. So Cassini-Huygens mission went there. So Cassini was the orbiter, and Huygens probe actually landed on Saturn. Can you imagine that? Okay, so that's an amazing, and there are pictures online which you should definitely have a look at. So, and this person was so humble, and he could wonder that the universe is so big and how small our actions are, and maybe they're not so important even to fight amongst ourselves. Okay, so that was Christian Huygens, and there's some connection to the rest of the talk. This is a picture of the Huygens eyepiece. In fact, you might see it in microscopes, but I think it can also be used as a eyepiece for a telescope. A slightly different modified version, which he used, it can generally be used in a make it yourself kind of a telescope. Okay, going ahead. Now, I'll tell you, after him, of course, people developed ways of finding out more about our planetary system. And how do we find out details about our system? We get samples. Okay, I just told you about the sample coming from Hayabusa, but you don't. That's the first time humans have actually gone and collected a sample and come back from an asteroid. People have collected material from the moon in the last century, but that's all. However, we are always getting some samples from the solar system, free of cost, okay, without any mission. And these would be the meteorites. So you've just heard of, I think, the meteor shower which passed by. Those who are in Mumbai or around the west of India probably missed it because of the clouds. But there are many such showers which go on throughout the year. So that's another thing. If you're interested in planetary science, don't say meteor showers are so simple things to observe. They can give you a lot of information about the solar system. Okay, and some of them even come down to the Earth. They reach down to the Earth without getting burnt up in the sky. You can, of course, infer things from looking at them burning in the sky, but then you can also infer things about them by seeing the fragments which come to the Earth. Okay. In fact, I know that there are fragments of lunar meteorites, which actually are pieces of the moon which have fallen to the Earth. There are Martian meteorites, which are confirmed pieces of Mars which have been found on Earth. So yeah, it's not so simple a thing. And these meteorites do have a lot of value to study. Again, the last bit here means that some of them are simple, like they're small pieces of rock, they can just land here. Some of them may be big also. Things like asteroids, which could be meters in size, if they reach the Earth's surface and hit it, they might even be dangerous. So the other thing that we study in planetary science is to track these objects up in space. Okay? That's also another important use of planetary astronomy, that we not just think of things here, but we also think of things going around in the sky and keep a track of them, so that we can know if any of them is coming to hit us at some point of time. Okay, that's through samples, but of course we also look at all these things with our radars and telescopes. And planets like Venus, etc., have been probed by radar way back in the last century, and now we are building some of the biggest telescopes in history. Okay, today mankind is going on, and they have telescopes. This is the picture of GMRT, Giant Meter Wave Radio Telescope, which is right next door in close to Pune. It is part of a much bigger telescope system called the Square Kilometer Array. Okay, and that is going to be one of the biggest telescopes, radio telescopes in the world. And it's so big that it is spread across 2 continents. It's going to be built partly in Australia and partly in Africa. So imagine that. It's so big. Just imagine if your ear could be such, the size of your building or something, how much better and finer details could you hear with it? Similarly, you upgrade a telescope which is already 45 meters across. So this diameter is about 45 meters for each dish of the GMRT. And then you make it a continent, 2 continents big. Okay, now you can actually hear like some electrical storm happening on Jupiter. It would be that sensitive. So that's through radio. And of course, then we also have some of the best optical telescopes coming up. The extremely large telescope, the 30-meter telescope, and the Giant Magellan telescope. These are going to come up in the next decade or so. And I think, this is one of the golden ages of astronomy which is coming up. And if you guys are interested, then only you can use these. These resources are going to be made by the present generation of scientists, but the next generation has to use this. So I am looking forward to you guys using them. They are also going to be great tools to study our solar system. Okay, Other than that, we can of course visit the planets. Okay, they have been very successful unmanned missions with a lot of rovers and landers, etc., going to various planets and taking great images and even doing a lot of things like spectroscopy, etc., which have given so much details about these planets. But this may change this century, and we may actually have somebody landing on another planet or another moon. So look forward to this happening. And again, a great subject to study if you want to indulge in any of these kinds of studies. So that brings me to one of the dreamers of last century, the 1900s, Carl Sagan. And then this is what he had to dream about and think about planetary science. He said, okay, after the telescopes were made, we had looked at the planets, we had noted down their characteristics, etc. He says, the job is by no means done. We've gone to the moon, but that's not enough. We will look for the boundary between the solar system and the interstellar medium. This is in predicting the future of space exploration in the next 2 decades when he was young. And then we'll voyage on forever in the dark between the stars. And it's quite rings true now that in 2012 and after that, I think 2014, the Voyager missions, okay, missions for which Carl Sagan himself was responsible. The Voyager missions actually crossed what is called the limit of the solar system and actually went into interstellar space. So Voyager missions were very important, and these were our visitors. But their prime objective, actually, you'd not believe, was not to go into interstellar medium. The prime objective, nobody had dreamed that they would keep going for 40 years. It was just a trial. Okay, but their primary objective was to actually take images of Jupiter and Saturn in a close-up. So they were fired out in such a way that with some gravitational slingshots, they would have to pass by Jupiter and then again pass by Saturn. And these slingshots would then give them enough speed to go outside the solar system. Okay, so of course, just rather than burn up fuel by into just sending something in one particular direction, what the scientists used was they burnt a little fuel, but then they used the gravity pull of Jupiter to actually, after a while, let Jupiter pull the mission, the satellite, Voyager 1 and 2, both towards Jupiter itself. But then, of course, the orbit was planned in such a way that they would not go and hit Jupiter. They would just go past it and then make a slingshot and go in another direction. And then the planning was also done in such a way that the Jupiter's position and the Saturn's position was calculated, and therefore they were launched in the 1970s, and they knew that after such a amount of time, when they go past Jupiter, if you align the orbit in such a way, in this particular way, then it will go in its next slingshot towards Saturn. Okay. This planning was very important, you see. So people were studying Jupiter and Saturn for many years, and they knew their orbits very well. So that knowing that itself is a very big part of planetary science. And let me tell you, that can actually be done very well with small telescopes as well. Okay, only it needs persistence, and of course you need a telescope. Okay, so Voyager missions were planned like that. They went towards Jupiter and Saturn. They took the images of the Saturn's rings, the best images before Cassini went there, of course, and of the larger moons. Again, some of the best pictures of Io, Ganymede, etc., were taken by these missions, and in general, the two planets were studied. And then the slingshot took them away towards interstellar space. Okay. Now, currently, this is kind of a cartoon picture again. So you can see this is the sun. This from a very far off distance outside in this interstellar medium. It looks like a tiny dot, okay, like a tiny star in the sky, just like any other star, except might be slightly yellow. And this bluish bubble that you see is kind of what the the solar system that we know of is like. Okay, and so this is Voyager 1 and this is Voyager 2, and you can see that we have discovered, because of their voyage into this particular zone, that there is a different kind of a wind, there's a different kind of a medium, and its shape is something like this, so that we can understand that the sun with its family, the solar system, is actually traveling through a medium. Okay, and it's got also a tail like this. So you can now look at the solar system itself as a core of a big comet, a huge comet, like, this size of a few solar systems. And so they've gone out now. So Voyager 2 is, in fact, also crossed the boundary of what is called the edge of solar system, heliosphere, and Voyager 2 is in between here right now. Okay. On them, they carried this Voyager Golden Record, and this is actually something like a CD. It's a phonograph. It's got grooves on it with a lot of beautiful music from the Earth, and also a lot of data, scientific data, that if found by an intelligent civilization, could actually tell them something more about the Earth and the way we do science. Okay, and also a little bit about how we communicate, so that they might be able to communicate back to us. Okay. So the content of this was actually designed by a committee which was headed by Carl Sagan. So this is I'm just remembering him, and in fact, 20th December is his death anniversary, and our event, which all this is about, is going to happen on 21st. So that's quite a nice schedule happening right here. So a person who spent a lot of his life on these missions, which studied Jupiter and Saturn together. Okay, one more thing which he said was that if the dinosaurs had a space program, they would not be extinct. And this really rings true in today's age, when we are studying the solar system through our planetary science, and we see the need for a space program, a peaceful space program, which will use the our space going capacity to actually deviate any dangers which are coming towards us. So I again stress here that observations are important, and observations of even small objects with small telescopes, or big objects with small telescopes, or small objects with big telescopes, all are equally important and very vital. So even as a newcomer to astronomy, if you have a small telescope and if you're studying the sky, if you're photographing the sky, if you're doing a survey, daily survey of the sky persistently, that could be of great importance, not just to science but to humanity. And I'm sure the asteroids which will be discovered, if there was such a major program going on, would really help us from an extinction level event. Right. Now let's go to the modern ages, 2000s, and with a very active astronomer. He is Michael Brown. Okay, and when I stood outside his office in Caltech a few years back, on his door it said Pluto Killer. Yes, so that is Michael Brown, Mike Brown, as he's known in a friendly way. So Mike is the person who was responsible for Pluto being demoted from planet to dwarf planet. Okay, and so everybody either hates him or loves him for this. But he is a staunch believer that yes, Pluto had it coming, because at some time we had stagnated. Astronomers kind of said, okay, fine, we have 9 planets, we look for the 10th planet. If we don't find it, our solar system is done for. But then that should not be the case in which science should stop. Okay, we should not say like Newton's time, maybe somebody said, okay, Newton has discovered everything, then there would be no place for Einstein. Similarly, you see what he says. He says that finding out that something you have just discovered is considered all but impossible. It's one of the joys of science. So what this means is that, that's the fun of science, that, when people start saying, okay, this is impossible, now you cannot discover anything more, and then somebody goes and discovers something, bang, here, that's the joy you get. Okay, so I'm not saying he's going to get a Nobel Prize or something, but just imagine just discovering even one planet or one small body in the sky is a great achievement. Okay, and he has discovered 4, at least, big bodies, and there are more things he's discovering with big telescopes like the ones I just mentioned to you about. Okay, he's going to be one of the users of them. So this is where we stand in the 2000s. Now we've not just known about the solar system, we know its giant size. We now are insignificant place in it. We've gone outside the solar system now with our Voyagers. We are now going further and actually trying to look and see things more clearly. Okay, so I'm sure Mike Brown or any of you students who maybe work with people like Mike Brown in the future might actually discover many more things in our solar system, things which may be useful, which information might be vital to us. Okay, so that is something which is coming up in the thing. And of course, I should show you. I mean, the things that some of the things that Mike has discovered, and there are some things which are there which have been discovered in the outer solar system. So the dwarf planets, which is a subject which is not so often referred to in textbooks, it's very important and very exciting. Okay, and after we deal with the known planets and their known things, there are things outside, much farther off than Pluto, and they are quite exciting. Okay, they're the cold worlds, and you see some of them here, and their sizes are also mentioned here in this corner here for the scale. So you can see Pluto is probably the largest, or maybe Eris, which was the Pluto killer kind of. The discovery of Eris meant that Pluto had to be reclassified because they were both similar size. Okay, so Pluto and Aries are there, very big. Haumea is a very elongated one. Yeah, and there's Makemake, and then there are a lot of smaller bodies, definitely known, like Quaoars, Sedna, Varun, Orcus, Ixion. This is our named body here. Okay, so these things are there out there, and planetary scientists are trying to discover them as well. Okay, so there's a range of subjects which planetary scientists study, and I just tried to give you a quick glance at what the science is and what are the exciting things that are still left to do. So coming to the present, coming back to our event coming up on the 21st of December, it is something called the conjunction. Okay. Now, a conjunction is two bodies basically coming together in a small region of the sky, in a close by region of the sky. I think there's a talk by Dr. Ratnashri about the conjunction itself and how you can observe it with very simple instruments. So I will just point out to that, and I will say that on 21st December, you definitely try out looking at this event, this portion of the sky in the southwest of towards the horizon, where you will see these two bright objects very close together. In fact, you may not think they are two bright objects. But how will you know? How do you know they are bright objects? Well, don't look at them only on 21st December. Start looking now. In fact, I've been looking at them for the last few months and seeing them slowly draw closer and closer while they become very close on 21st. So that's like, it's like, looking at a race, Olympic race. So you don't just look at the last snapshot of it, right? You look at the whole race and enjoy them going together, and then enjoy the process of one, leading over another. And then there's the winner moment. Okay. So the winner moment is on 21st, but that's not, all. So definitely have a look, start looking at them now. Maybe it's better if 21st is cloudy, you see something at least now. Look at them now, look at them afterwards, see them separate out and go their own ways. And as I said, if this is going to be your first step at planetary science, it's a good time to start, because it's a very momentous occasion. Both these planets coming together after 400 years, as we are being told, is not such a small event. So look at them. There's also Mars in the sky, unmistakably red, and this will be almost high up from the horizon towards the east side. Okay, so go have a look at that also. And if you want to follow them from after this, I will suggest that you either get yourself a telescope or make a telescope. There are various programs at Nehru Center, at the Nehru Planetarium also. You also have some programs at IUCAA in which you can make your own telescope. Yes, it is possible. You don't need to be Galileo. And Galileo was actually a very ordinary person with even less resources than what we have in the modern age. He could make a telescope. Newton could make a telescope. Huygens could make a telescope. Why can't we? So go make one. If you can't, go get one. Okay. Ask your parents to get one for you, a young kid. And I suggest that you just don't satisfy yourself on 21st December and finish with it. You want to really try out planetary science, let this be your first step. Get the telescope or borrow a telescope, and keep looking at them. Keep looking at their positions. Keep looking at the positions of the moons. Keep looking at, try and see if you can see Saturn's moon from here, what Huygens had discovered. Okay, so all these things are possible and they await you after the Jupiter-Saturn conjunction. So I would suggest you make the best of this event. And of course, if you can, you make the cross staff, which has been challenged in the Samant Chandrasekhar challenge by Dr. Ratnashree from Nehru Planetarium. So go to that video also and have a look. With that, I will finish this talk, but if there are any questions, I'd be happy to take them. In case you are shy and you want to email me, this is my email. I'll keep it on.
Yeah. Hello, Juma. Yeah, you can see actually if some questions are there, we can take up a couple of questions. Mr. Samir has already told our audience how it is simple, I should say, to follow this astronomy and do something at home. Making a telescope is also not a very big challenge nowadays. So many institutions like Ayuka and Vigyan Prasad, Nehru Science Center, Nehru Planetarium, they keep encouraging people making small telescopes, and I think they can do. Otherwise, there are many programs like ours and other institutions who are conducting these programs live. And now we are open also, maybe on weekends, with maintaining social distances, physical distances. People can visit us. We can show them because numbers are small, so we can accommodate live also at our place. And he has also mentioned many things about simple things, which perhaps, but in a very different way, I should say, because I remember when we were in schools. Generally, now there are 8 planets. At that time, there used to be 9. But the basic definition was, हम लोग हिंदी मीडियम में पढ़ते थे तो बोलते थे कि सौर परिवार की परिभाषा बताइए, तो कहते सूर्य के 9 ग्रह के सौर परिवार क्या है. But just as you told, there are dwarf planets or comets, dust, gas, and the most important that we are also existing. We never consider ourselves at that time that okay, we are part of solar system. So these things are some maybe a different way of telling people. You can say whatever you always see or read in the books. I remember there was one lecture. Is that science is not something which you read in books. Something you have to do practical. So that's how perhaps we can do. Yeah, Juma, if some questions are there, you can share it, or you can ask or present it to Mr. Samir.
Yes, we have few questions. We have one question from our visitor Chaitali. She's asking which is a good standard telescope for home observations. Kindly recommend.
Yeah, Mr. Samir.
Very good question. So, for basic observations, if you want to just start off, like if your child is, you're a child, sorry, don't know your age, but general for parents, my advice is that if your child is about 10 years old or so, you should invest in a refractor telescope, which is 2 or 3 inches in diameter. They are made out of the primary for them is a lens. Of course, the quality should be good. But if you really want to challenge your child and actually give them a direction towards doing better observations, I will suggest getting at least a 4 or 5 inch reflector telescope, or better still, as I happen to be lucky enough to get in my school days. So when I was in like 9-10 standard, I got access to something called something like a 6 inch diameter reflecting telescope. So it was a Newtonian telescope. Of course, it was taller than me at that time, and it was quite bulky to carry around. But my teachers would help me. My parents, they were happy to let me go out to my astronomy club, and that's another support that I got. For a high school kid, it's really good, and I think a lot of things can be done with it. And as I said, these telescopes are easy to make, and in fact, I'm sure, I'm confident that the Nehru Planetarium has some reflector telescope making programs, in which you can actually make 6-inch or 8-inch telescopes. So well tested ones. So these telescopes can show you Jupiter, etc., really well, along with some of its satellites. And I have also seen, as I said, two satellites of satellites Titan of Saturn with this kind of a telescope. Plus, as I said, they can also see various other dim objects like nebulae, galaxy, etc. And if your child has a engineering mind, I'm sure they can make a lot of modifications, a lot of jugaad to use them for astrophotography as well. So I will suggest for a young child, maybe a 2-3 inch refractor with a good stand, and for a older child, I would suggest a 6-inch refractor, reflector, 6-inch reflecting telescope, probably a Dobsonian or any other.
Category, schematic category, that can also. Okay. Next question.
Another visitor, Ashwinder Kaur, has asked, can you suggest a program where we could make a telescope?
Yes, I think I just answered that. But just to repeat, I think I'm sure the Nehru Planetarium has a reflector telescope making program. Ayuka has a reflecting telescope making program, which is regular. But otherwise, there are special workshops taken by Nehru Center Mumbai, Nehru Science Center Mumbai, and otherwise organizations like Vigyan Prasar, etc. However, I think you can also look it up online. There is an online book by Dr. P. N. Shankar, one of the best books on amateur telescope making. Okay. So just look up how to make a telescope by P. N. Shankar, and there is a file, and we have kept it open source. So go through it. There are several things which are mentioned there, and making a telescope is up to you. How you make it and whether you will be able to make it is up to your effort and your enthusiasm. So because the material has to be brought from the market, it's available in the hardware shops, right? It's not something which you have to buy from a particular person. It's basically glass blanks, glass pieces which you buy from a glass shop, some carborundum grit which you buy from a hardware shop. Okay, then there is tar and pitch and some scales, some things like that. So all these things are available in the market in the hardware shops. So it's up to you whether you want to go out there and buy it. So there are people, of course, who have not needed any program particularly, but they've gone and read this book and been able to make their own telescope. As I said, if you need, we are there, and our you can always contact us at our email ID.
Okay, another visitor, Jayantila Nikam, is asking what kind of image is obtained from GMRT, single image or from number of disks or one image by each?
Yeah, it's a okay, it's slightly unrelated, but the GMRT is something called an input, and it's basically the whole all the dishes, the 30 dishes, or some part of them actually make one image. But the data has to be combined at certain phase and things like that, and then interfered, as it is called, interference, and then we get a sky map of the radio image.
And his another question is what time we can see the conjunction? He's asking about the time.
Conjunction can be seen, as soon as the sun sets, they should be visible in the southwestern sky. In fact, that's why I'm suggesting that you start right away. Just go there outside in the evening. West is very clear with the sun setting in that direction, and in fact, the sun is almost at the peak of its Dakshina end, right? So it's the most south position on 21st. So southwest would be very difficult to find out. Look in that direction. You should find one bright and one slightly lesser bright dot in the sky. These are Jupiter and Saturn. They would look amazing, of course, if you had a telescope, and you could also try using your binoculars. Don't discount their power. Look through these, and you should be able to now, because of them being very close by, should be able to see them both together in one field. So you just point at them, and they'll be both there at the
Very cool.
That is very rare to see. That's why we are all excited to maybe take a picture of both of them together.
Yeah. Since actually we had got some information that though the peak of congestion is somewhere around late night or maybe 9:50 or somewhere, but in Mumbai particularly, I think people should look out for their local sunset time. And since, as you told, this is the time when I think 21st, that's the day when your longest night or maybe shortest day. So you can start a bit early. Yesterday I could locate Jupiter maybe around 6:15 in the evening. I mean, since I see it regularly, perhaps it is easy to find out. But if people will start, as you said, early, or maybe from today itself, perhaps on 21st, it will be easy for them to locate for that. Whether a pinhole camera will also help, but to take some picture or maybe they will able to create in that, whether intensity will be that.
That's a good question. So I didn't mention the time because you have an all India audience and their sunset times may be different. But just after sunset, you should be able to find them in the southwest. And if you have a good zoom lens, you could put your camera on a stand, steady it, and then zoom into that direction. Okay? Look through your eyepiece and then zoom into that direction. And I think you should be able to get a fair image of that with a zoom lens also. Anything between 200 400 mm focal length is good, and these days many power shot kind of cameras have that kind of focal length, so it's not a rare thing.
I think children should think some in an innovative way. You have used the right term called jugaad, and that's what we are very good, particularly in India. There are a lot of things about that. People should try for that. Any other questions, Jugaad?
No.
Because we are delayed, so we can conclude then. Okay.
Yeah.
You have told many things. In fact, that's one thing very important. You have for young children or audience who are watching this show. A lot of things like astronomy, particularly if you want to pursue, it's a multidisciplinary subject. You can, whether you are in chemistry or biology or physics or mathematics, I think all of them are subsumed in the field of astronomy, and they can pursue that. And a lot of some facts also you have shared with us. I remember in one of the planetary show, I saw a sound which you mentioned about some electrical storm between Jupiter. But I think that Io and Jupiter, there are some connections between that, and that kind of sound was recorded and it's shown in one of the planetarium show. So, and now you said to that extent we can go in astronomy, that you can listen what is happening out there. It's a very, very challenging and interesting field. There is no doubt about it. Mr. Samir has shared a lot of things with you all. You just need, in fact, nature is revealing a lot of things to us by sending those samples of asteroids that you keep on studying them and know about astronomy. So you can visit us. You can visit Ayuka Pune also. Very good campus they have, and I think they are entertaining school visits as well. I don't know public visits are allowed or not, but that's.
We are still under lockdown, but we hope that next year we can open up.
But anybody can visit for that on for outreach program and all that. Okay, so thank you very much. And if any other question is there, he has already shared the email, or you can share your questions with us also. We can forward to Mr. Samir. Yeah.
So our brand, it is called is SciPop, Science Popularization, SciPop. Just look up SciPop on Google, we get our Facebook, Twitter, it's all Ayuka SciPop. And we also have a YouTube page, so just go there, you'll find a lot of good informative talks and other activities there. Thanks Nehru Center, Nehru Science Center.
Nehru Science Center, Samir ji, आप तो कम से कम Nehru Science Center बोलिए.
Nehru Science Center.
Yeah, no, thank you. Actually, that happens. I just be there because you know, Nehru Center is slightly different organization. We are Science Center.
I apologize.
No, it's all.
Science Center.
Yeah,
Great place. Please visit it.
Yes, thank you so much. Okay, thank you all. And now we can conclude the meeting, Juma. Thank you. And let us. This will be available on Facebook page also. If those were missed and they want to see it again, they can do that. Thank you.
Okay. Thank you.
Thank you so much.